Hello guys, in today's video we're going to see a Karp reduction from the subset sum problem to the Approx Subset Sum Problem. Both problems are NP-complete. We can prove that the Approx Subset Sum Problem is NP-complete by showing a Karp reduction from the classic Subset Sum Problem. But before getting into the action, let's match our expectations. My videos depend on the wisdom of the crowd, a topic that really fascinates me. Since I'm studying this topic by myself, there might be an occasional mistake in what I say. Please correct me in the comment section below if you wish to correct me, of course. I promise to read all comments and we upload if necessary. Together, we can answer tough questions in a better way. Also, please subscribe to my channel. Your free subscription will greatly help me to make my project more accessible to all. The subset sum problem is getting a set of integers and another natural number, and we need to determine if the set of integers has a subset that equals the given natural number. The Approx Subset Sum Problem is very similar to the classic problem, but returns true if the set has an almost equal subset to a given integer. In our definition, almost equal is plus minus 10 the actual value. The solution can be implemented, however, for any range. Let's look at the solution.
Alrighty. Subset sum problem. Given a set of integers a and an integer b, we need to determine if there is a subset of set a which its sum equals to the given integer b. For example, say a equals 1, 2, 3, 4, and 5 and b equals 7. These subsets, for example, solve the problem. We only require one. I did not mention the all subsets equal to 7. So 4 and 3 of course equals to 7 because 4 plus 3 equals 7 and 5 plus 2 as well. Approx Subset Sum Problem. Identical to the classic subset sum problem except that if we find a subset which is smaller by up to 10 units or bigger by up to 10 units than b, this subset satisfies the problem. Solution. We will call the number of allowed units 10, in our case n. In other words, n equals 10. We will craft a new input to the problem, in which we multiply any element by n plus 1, every element of the original set A and our integer b. Therefore, we would multiply every element by 11. For example, say A equals 1, 2, 3 and b equals 1. The modified input is 11, 22 and 33 and b equals 11. Phase direction. Assume that AB in subset sum, therefore we have a subset of set A which equals the integer b. We will call it subset D. We want to show that A prime B prime in Approx subset sum. In other words, we want to show that we have a subset D prime consists of elements from the set A prime that equals B prime. Let's see that. We start with sigma D in D, D equals B. We want to reach sigma of D prime in D prime equals B prime. Let's do some math. Sigma D prime in D prime equals B prime. That equals to sigma D in D of 11 multiplied by D equals to 11 multiplied by B. Let's write it differently. 11 equals sigma of D in D, D equals 11B. Let's multiply both sides by 1 divided by 11. We get sigma D in D, D equals B. And we reach the assumption we assume is correct. Therefore, we completed this direction. Second direction. Assume that AB not in subset sum. We want to show that A prime, B prime not in Approx subset sum. Assuming contradiction that A prime and B prime is in Approx subset sum. Therefore, we have a subset D prime which fulfills B prime minus 10 lesser or equal to sigma D prime D prime lesser or equal to b prime plus 10. Let's do some math. b prime minus 10 lesser or equal to sigma d prime in d prime lesser or equal to b prime plus 10. That's by the definition of d prime and b prime. So we get 11b minus 10 lesser or equal to sigma d in d 11d lesser or equal to 11b plus 10. Let's write it differently here, and we are dividing all sides by 11, and we are getting b minus 10 divided by 11 lesser or equal to sigma d in d lesser or equal to b plus 10 divided by 11. We would notice that the only integer in the range of b minus 10 divided by 11 to b plus 10 divided by 11 is b itself. Therefore, we see that b is lesser or equal to sigma d in d lesser or equal to b. Therefore, we see that sigma d in d equals b. And we found the subset of set A which equals to b. Therefore, A and B is indeed in subset sum, in contradiction to the assumption that AB not in subset sum. From Contra-Positive, we see that if A prime B prime in Approx Subset Sum, then AB in subset sum. In conclusion, we saw that AB in subset sum if and only if A prime B prime in Approx Subset Sum. Therefore, Approx Subset Sum is also NP complete.
Well, that's about it. I hope you learned something new from this video, and please comment below with your thoughts. First degree studies in university are all about social studies, and this project comes to encourage that, even throughout complicated situations most of us are going through right now. Please subscribe to my channel. Until next time, good luck.